Hi, the purpose of this video is to go over a homework problem with you. And so in this case, I'm going to go over this problem, chapter 10, problem 15, about refrigerator longevity. So we're going to read the problem. A consumer advocate researches the length of life between two brands of refrigerators, A and B, and then he collects data on longevity of the refrigerators, and he reports on them. So these data are measured in years and can be found on the text website. So I'll pull that for you in a second. And of course, they're labeled refrigerator longevity. So number A is we want to specify the competing hypothesis. So in this problem, what we're trying to do is determine if the refrigerator longevities between brand A and brand B differ. So the assumption is they do not differ, and so what we want to do is test the hypothesis that they do differ. So we're going to set it up as the longevity of A is going to equal to longevity of B, and then we're going to try to reject that hypothesis in favor of the alternative, and that is that the longevity of A is not equal to the longevity of B. And we would write that something like this. Okay, so you can see I have written out the two hypotheses. Now I just want to clarify something. So up until this point we have been using these mu's, mu A equal to mu B, although my B is a little difficult to read there. Let me fix that up for you. So I just want to clarify that over here my notation A and B is different because really, to be exactly correct, what we want is this A, and we want it annotated like this over here because really we're talking about the mean of A group A and then compared to the mean of group B, and then down here that they're not equal, group A and group B. And I don't know why my tablet, oh there, did it updated finally. Okay, so that's answers question A. Now we're going to go in Excel and compute the value of the test statistic. So what you want to do is stop this video right now and go get the data out of chapter 10 called refrigerator longevity, and then meet me back here. So here I've pulled up the refrigerator longevity problem. Mine looks probably a little different than yours. I colored it and organized it a little bit, but basically same thing. So now down here at the bottom of this, down here at the bottom, I went ahead and took an average and a standard deviation. Now some of that is because it's just the way I like to think about this stuff. I like to think about the idea that basically we have two regular distributions, and we're trying to see how similar they are and do their tails overlap. So this helps me to see that, and I'll get back to that in a little bit. So because they gave us in the problem that the variances were known, we can do a different test in here. So let's go up here. So we want to go to data, data analysis, and we want to choose this one here, the way bottom, called z-test 2 sample means. So we say okay, and then we're going to highlight variable range in 1. So here we've got brand A, so I think I'm going to include brand A, and then highlight the column, but I have to be careful to back out my mean and standard deviation because I don't want to include that. And then go back up here and get my second variable. I want to also include brand B, highlight it down, and of course I just want to bring it back up to just a 17 because I don't want to include the mean and standard deviation. Okay, my hypothesized mean difference is 0 because remember I had mu equal to mu. And then my variable variance, if it's known, so they tell me in the problem that assume that brand A is 4.4 and brand B is 5.2. So I have those put in there. In my case, I do have labels, so I want to put that in there. I want it to be significant to 0.05. And then I'd like to have my output right here so you guys can see it nicely. And then I'm going to hit OK. Now, what I always like to do before I start messing with this is to switch the font over. I just don't really like that font, and I like this better. And then I like to make this big enough that I can see everything, and then I generally will turn all these into numbers and maybe increase the, not currencies, but numbers, and then increase the decimals a little bit because we need to have enough decimals that we can see what we're doing here. Now, we don't need decimals with the number of observations, of course, because that's just 40 and that's fine. Let's see if there's anything else we need to mess with here. So we want to know what type of test we did. We did this z-test for 2 sample means. And then this is what we're after right here. I think one of the things that is the most confusing about all this is which number on this thing do you even look at? And so I'm here to tell you this. In this case, it's this one here, the z value. And we can see pretty clearly there is definitely a difference, right? I mean, there's a difference of 1.47. You know, broadly, that's about what it says. But what we want to know is if our difference is different enough that we can say these two samples are statistically different. So remember, it's one thing to say they're different. I mean, obviously 16.52 is different from 17.25. But is there enough difference that we can say they're statistically different? And what I want to do is sort of draw this out for you so you can sort of visualize this difference that we're talking about. So what I did here was kind of grossly draw this. Basically, we have two distributions here, right? We've got this one here, and the mean is 16.25. And we have this red one here that I redrew, and it didn't take my second line. But anyways, with the mean of 17.25. This 18.625 here represents one standard deviation up from 16.525 is here. So see, they obviously overlap. So before we ran our stats test or whatever, we could kind of tell that they're not different enough. I mean, yeah, they're different, but they're just not different enough. So our hypothesis is asking if they're equal or if they're not equal. So even though the average for A is indeed different than the average for B, it's not sufficient for us to say, yep, absolutely, they're different. So what happens is we cannot reject the null in favor of the alternative. Instead, we have to say, the answer would be we cannot reject the null at the 5% significance level. So let's just take a look here at the Excel and what it told us. So it told us that our critical value needed to be 1.64, and our value was actually 1.47. So it is not enough different for us to say, yeah, absolutely, they're different. So in this case, the answer would be to, we cannot reject the null. So, because it asks us, use the commands in Excel. So we did that in Excel. And then C would be, we cannot reject the null. So given these samples, we cannot reject the null. Essentially, they're different, but they're just not different enough. So we might write something like this. Given these samples, we just can't reject the null in favor of the alternative. So this is problem number 15, the refrigerator longevity problem, and I hope you found it helpful. Bye.